Redox equilibrium 1.1 oxidation and reduction. This is part 3. So in this subtopic, we are going to go through 3 chemical reaction where the application of redox were applied. Number 1, conversion of iron 2 to iron 3 and vice versa. Number 2, displacement reaction of metal from its salt solution. And number 3, displacement reaction of halogen from its halide solution. Okay, halogen, elemen dalam group 17, halide, solution yang ada ion daripada group 17, which is chloride, bromide, iodide. Okay, now we go to the first one, conversion of iron 2 plus to iron 3 plus. So what is the difference? The charge, okay, from 2 plus it changed into 3 plus. So if you have understand about increasing of oxidation number, so process here is oxidation, okay, but actually it happened same time with the reduction. Okay, conversion of iron 2 plus to iron 3 plus. What happened is we put the bromine water into the iron 2 sulfate solution. So iron 2 sulfate actually is green color at the first place. When bromine is added, the green color of iron 2 sulfate changed into brown color. Okay, and brown precipitate with sodium solution. After the reaction, the iron 2 sulfate solution has been changed into iron 3. So the solution is taken and tested with sodium hydroxide, and it will show brown precipitate. It shows that the presence of iron 3 plus ion. Okay, next one. I need you to complete the handout in page 12. Okay. Okay, next one. The oxidation number of bromine decreased from 0 to -1. Okay, we see here bromine, the oxidation number is 0, and bromide, the oxidation number is -1. So what happened? Bromine has been reduced. Okay, bromine has been reduced. Okay, it is said that bromine accept an electron to produce bromide ion. Okay, while what happened to iron 2 plus? The oxidation number of iron in iron 2 plus, yeah, increases from +2 to +3. Okay, ya. Oxidation number of iron. Bila kita sebut pasal oxidation number, you kena ambil bromine, for example, and iron. Kita sebut elemen dia sahaja. From +2 to +3. Iron 2 plus ion will release an electron to produce iron 3 ion. So, iron is said to be oxidized. Increasing of oxidation number. Okay, please jot down in your handout, okay? Next, ionic equation is 2 Fe2 plus bromine to produce 2 iron 3 plus ion and 2 bromide ion. Okay, so half equation, okay, just separate from the ionic equation above. We will get iron 2 plus become iron 3 plus by release 1 electron. Explanation, iron 2 plus ion will loses 1 electron to form iron 3 ion. Iron 2 plus ion oxidized to produce iron 3 ion. The ion oxidation number increases from +2 to +3. So iron 2 plus has been oxidized. Iron 2 plus also known as reducing agent. Now we go to the second part, which is reduction. Bromine has become bromide by receiving 2 electrons. So bromine molecule accept 2 electrons to form bromide ion. Bromine molecule reduced to bromide ion. The bromine oxidation number decreases from 0 to -1. This is 0 value. This is -1, referring to the charge. Okay, so bromine has been reduced, and bromine also known as oxidizing agent. Okay, so oxidizing agent is bromine water or just bromine. Okay, complete your handout. Now we go to the second one, which is in page 13, conversion of iron 3 to iron 2, the vice versa of the first section. Okay, the solution change color. Okay, what is the experiment? Just take a spatula full of zinc powder and add it into iron 2 sulfate solution and shake the test tube or the boiling, I think the test tube. So what happened? The brown color of iron 3 sulfate will change into green color, while the green precipitate will be occur when the solution, the mixture, were added atau take out some mixture meaning mixture between zinc and iron trisulfate, and it actually has become iron 2, and tested with it's not tested, put into another test tube and aided with a little sodium hydroxide solution, and the green precipitate will be formed. Now, okay, experiment kita akan buat kemudian. Next one, okay, the equation. Okay, we will see here Fe3 plus react with a zinc to produce iron 2 plus and zinc ion. Okay, so we see the zinc first. Zinc atom, the oxidation number is 0. It will become zinc 2 plus. The oxidation number is plus 2. So what happened to oxidation number? It is increasing value of oxidation number, increasing oxidation number. So the zinc is said to be oxidized. Atau oxidation is occur to zinc. The oxidation number increased from 0 to plus 2. Zinc actually releases electron to produce zinc ions. So zinc is said to be oxidized. What happened to iron 3 plus? Iron 3 plus, the oxidation number is plus 3, while Fe2 plus, the oxidation number is plus 2. So the oxidation number of iron decreased from plus 3 to plus 2. Remember here, iron, iron, it's not iron 3 plus, just mention iron. Same goes to with the zinc. Okay, so reduction is occur at iron 3 plus. Iron 3 plus ion accept electron to produce iron 2 ion. Ionic equation for iron 3 plus change into iron 2 plus. Okay, so this is the ionic equation. Half equation is zinc, tambah zinc atas ni, will become zinc 2 plus by release 2 electron. Okay, zinc atom loses 2 electrons to form zinc ion. Zinc oxidized to zinc ion, or in symbols is Zn2 plus. The zinc oxidation number increased from 0 to plus 2, so zinc known as reducing agent. Okay, how about the second one? Fe3 plus receive 1 electron and will become Fe2 plus. Iron 3 plus ion accepted 1 electrons to form iron 2 ion. Fe3 plus reduced to iron 2 plus. It shows in the equation, the half equation. So the oxidation number for iron decreases from plus 3 to plus 2. So the oxidizing agent is iron 3 plus ion, or iron 3 sulfate. Okay, either one from those 3 selection. Now we go to the second one. Okay, displacement reaction of metal from its salt solution. Okay, displacement of metal is carried out by adding a metal into a salt solution of another metal. Apa bondanya tu? Okay, so we have a more electropositive metal, which is, for example, here we have zinc. Okay, so we put into a solution named copper to nitrate solution. So I think you should imagine what is the color of copper to nitrate solution. What is the color of copper to nitrate solution? Yes, right, blue color. So when we put zinc is gray color, into copper to nitrate solution, something will occur. Let us see afterwards. Okay, the blue color of the solution, which is the copper nitrate, okay, will become paler because the concentration of Cu2 plus is decreased. Okay, brown solid is deposited because that brown solid actually is copper. Okay, the copper will be formed. Okay, the copper will be kicked out from the copper nitrate by zinc because zinc is more electropositive. Okay, copper to ion receive 2 electrons to form copper atoms. Copper to ion is reduced. Yeah, oxidation number from plus 2 to 0. Oxidizing agent is copper to ions, or we will see it as copper to nitrate pun boleh. Okay, what happened to the zinc? Zinc become thinner. Zinc atom ionized to form zinc ion. Zinc atom will release 2 electrons to form zinc ion. So it is said zinc has been oxidized. Reducing agent is the zinc. Okay, you have to complete page 14, okay? Okay, kita pergi bawah dia pula. Make kau terus je. Okay, oxidation, half equation is zinc. Atom will become zinc 2 plus. It will release 2 electron. Okay, complete the 2 electron. Zinc atom release 2 electrons to form zinc ion. So half equation for reduction, Cu2 plus, ion receive 2 electrons and become copper. So fill in the blank, please. Copper to ions, which is Cu2 plus, receive electrons to form copper. Okay, complete the ionic equation. check the electron first. Dua elektron sama. So tak ada masalah. Just kumpulkan before dengan before, after dengan after. Arrow So zinc plus Cu2 plus to produce ataupun to form zinc 2 plus plus Cu. This is zinc Cu2 plus ya. Jangan buat plus 2. Cu2 plus. Ikut dalam handout awak. Saya punya slide tak betul. Okay. So the chemical equation is zinc react with copper to nitrate. It will produce zinc nitrate and copper. The brown solid is copper. And why the copper nitrate, which is the blue color, become pale? Because in the solution now, the name of the compound will be zinc nitrate. Tak ada lagi dah Cu nitrate. The Cu has been kicked out by the zinc. Kita jangan sebut kick out, kita sebut displaced by, okay? Zinc is more electropositive, so zinc will displace copper. So copper has been displaced by zinc. Next one, electrochemical series. Apa tu? Okay, saya suka sebut electrochemical series as the ECS. Saya ambil E, saya ambil C, saya ambil S. ECS. Tapi bila jawab exam, jangan sebut ECS. Memang salah. Electrochemical series. Okay. Electropositivity is the tendency of atoms to release electron to form cations. What is cations? Ion positive. So, electropositivity ni in Malay saya senang cakap ke-excitedan. Is that Malay? How excited the atoms to become a positive ion by release electron. Okay. Ada excited sangat. So, dia akan berada di atas. Atas apa? A series. That series lah. Tapi yang kurang excited, dia akan duduk kat bawah series. Okay. So, ke-excitedan. Kita tak boleh sebut excitedan lah. So, the tendency of atom to release electron to form cations. Electrochemical series is a series of metal that are arranged according to standard electrode potential. Bulat ni kita panggil apa ya? E prime. It's not prime. Prime, saya lupa lah. E naught ya? E naught. Yes, E naught. E naught. Standard electrode potential or E naught. In the order of most negative to most positive. Okay. Atas most negative, bawah most positive. Oh, macam tu. More electropositive metals are stronger reducing agents because the E naught value is more electronegative. It's more negative. So atoms are easier to lose electrons. More electropositive metal yang berada di atas lah ya dalam ECS are stronger reducing agent. Okay, known as a very strong reducing agent because the E naught value is more negative. So atoms are easier to lose electron. The electrochemical series that is part of the standard electrode potential. That is a new term for you, which is standard electrode potential. Nanti kita pergi lebih lanjut. So this is our electrochemical series. Okay, it started with the K+, Ca2+, okay, potassium ion, calcium ion, sodium ion, magnesium ion, aluminium ion, zinc ion, iron 2 ion, stannum ion, lead ion, hydrogen ion, copper ion, and silver ion. Okay, you can see the E naught value here. 2.92 is negative sign. So the more negative the E naught for each element, so the electropositivity is higher. Okay, dia duduk kat atas lah. Tapi kalau kosong, siapa? Hydrogen. E naught dia kosong. So kat tengah sini, it's not really tengah lah. Dia border lah. Okay. So E naught yang positif dia akan berada di bawah. So kita baca sikit kat sini. Dalam handout awak pun ada, more electropositive metal are located at the higher position in the electrochemical series. The reaction that take place involve the transfer of electron from metal atoms to metal ion. The more electropositive the metals, the easier it is for the metal to release electron. Yang atas lah ya, more electropositive. Metal at the top of electrochemical series are stronger reducing agent. In contrast, the lower position of metal ions in the electrochemical series, the easier it is for the metal ions to receive electron. Maksudnya yang bawah ni lagi excited nak terima electrons. So is it? Yep. Metal ions that are located at the bottom of the electrochemical series are the stronger oxidizing agent. So kalau atas stronger, see, reducing agent, yang bawah stronger oxidizing agent. Itu antara benda yang awak kena ingat lah. Now we go to the third one. Is it the third one? Displacement of reaction of halogen. Yeah. Dalam handout awak tak ada nombor 3, so boleh letak lah. Buku surat 15 bawah. Okay, halogen. Kalau ingat lagi, halogen is group 17 element. Kita ada fluorine, chlorine, bromine, iodine, astatine. Okay, so halide solution ialah for example, hydrogen bromide, hydrogen chloride, hydrogen iodide. Biasanya kita partner dengan hydrogen lah. The atom of halogen receive electron to form halide ions. Halogens undergo reduction reaction and act as oxidizing agent. The reactivity of halogen decreases down group 17 from top to bottom. Okay, halogens become more difficult to receive electrons. The strength of these halogens as oxidizing agents decreases. Conversely, it is easier for the halide ions to release their electrons, and the strength of halide ions as reducing agent increase. Kau faham ke benda ni? Okay. Nanti kita tengok contoh. Kalau tak faham juga, kita baca 2-3 kali lah. Okay, number 3, the displacement of halogen is carried out by adding halogen into solution of another halide. The halogen at top of group 17, more reactive, can displace the halogen at bottom from its halide solution. Okay, don't worry guys. Biasanya kita guna 3 saja. Chlorine, bromine, iodine. Dia tak akan pergi sampai astatine. Gila kot. Astatine sangat radioaktif. So, dalam soalan pun tak akan keluarkan. Chlorine, bromine, iodine. Ia ikut sequence dia saja. From top to bottom. Chlorine, bromine, iodine. Okay. Okay, now. We go to example. Terus je. Example gambar dia dekat muka surat 15. Okay. Displacement reaction halogen from its halide solution. For example, we have chlorine water added to potassium bromide solution. Okay. And added with some organic solvent which is 111 trichloroethane. Ini dah boleh patut lukis ni. Okay. So halogen in aqueous solution, halogen in 11 trichloroethane. 11 trichloroethane ni sebenarnya membantu kita nak kenal which halogen consists in the test tube. Okay. So when those two reactants are added to each other in a test tube, observation will be the potassium bromide change color from colorless to brown. Okay. So actually bromine is formed. Okay, bromine terkeluar daripada KBr. Kenapa? Biasalah. Dia cerita dia macam metal tadi juga. Chlorine will kick out. Salah. Chlorine will displace bromine from potassium bromide. So bromine is formed. Okay, bromide ion will release electron to form bromine molecule. Bromide ion is said to be oxidized. The color of chlorine water asalnya greenish yellow, it will become colorless. Chlorine molecule accept electron to form chloride ion. So chlorine is reduced. Okay. Okay, kita pergi yang seterusnya. Ada jadual di muka surat 16. Okay, minta tolong lengkapkan juga ya. So what happened to half equation for oxidation? Bromide ion will become bromine by release 2 electron. Okay, ini molecule ya. Buka betul tak? Ya, betul. What happened to my slide? Okay, reduction half equation. What happened is chlorine is receiving 2 electron and become chloride. So chlorine molecule accept electron to form chloride ion. Okay, so chlorine is said to be reduced, has been reduced. Okay, so the ionic equation, what was happened is bromide transfer an electron to chlorine. Sebab tu chlorine terima, bromide release. Siapa yang terima? Chlorine lah. So bromide will become reducing agent while chlorine will become oxidizing agent. Bahan yang mana mengalami oxidation? Bromide. Bahan yang mana mengalami reduction? Chlorine. Okay, awak boleh conteng ya ke awak punya handout. Kau jangan biar je macam tu. Okay, so apa-apa cerita kebanyakan ni pada reactant. Bukan kebanyakan, memang you kena sebut reactant. Okay, so this is our chemical reaction. Potassium bromide, a colorless solution, react with chlorine water. Okay, greenish yellow solution. It will produce bromine, brown color solution juga ya. And potassium chloride colorless solution. Okay. Ada lagi sikit ke? Oh, ada group 17 element. Yes. Okay, ini kita nak fahamkan reason dia. Okay. The higher the position of element in group 17, halogen, it is a well-known oxidizing agent. Okay. Manakala yang bawah pula adalah reducing agent. So, bergantung dengan siapa mereka berjumpa. Atas oxidizing agent, bawah reducing agent. Okay. The more reactive the halogen, okay, the easier for the halogen to accept electron. Okay, siapa yang kena accept electron? Yang atas lah ya. Oxidizing agent. Oh, sorry. Easier for halogen to accept electron. Okay, bila dia accept electron, dia akan menjadi reduction process. Okay. So, dia akan jadi oxidizing agent. Okay, yang atas lah. Betul lah yang atas. Okay. Halogen that are located on top of group 17 are a stronger oxidizing agent. Saya tengah baca yang kanan ya. In contrast, the lower the position of the halide ions of halogen in group 17, the easier it is for the halide ion to release an electrons. Okay. Halide ion of halogen that are located at the bottom of group 17 are a stronger reducing agent. Okay. Kalau ikut handout kita dah habis. Okay, macam ni ya. Ada beberapa yang you tak faham pada 3 cases ni. Please refer to the textbook first. Textbook sebenarnya terangkan pun bagus juga sebenarnya. And kalau tak faham juga, PM saya. Ataupun ada certain lah. Ataupun sebenarnya lagi bagus nak build up you punya kefahaman ialah latihan. Saya akan cuba cari nanti. InsyaAllah. Okay, that's all for today. Thank you.